So this presentation is available, at the short link bit.ly/ycrc -r-super. I can, let's see if I can just quickly post that in the chat as well. And we will be probably also sharing this with you all afterwards. So don't worry about taking copious notes because these slides will be available. For today, I wanted to take a different approach than oftentimes we take at the YCRC for an introduction to the clusters. We focus heavily on sort of understanding more deeply a lot of the tools that are sort of underlying some of these graphical things that I'm going to talk about. And instead, I just want to focus on sort of the bare minimum to get you up and running and have an RStudio window on one of the clusters that we maintain. And the idea is maybe this is like your little taste of what you could be doing. And then, as you progress and as your computations expand in scope and needs, then, the rest of the cluster and the functionality that it provides is available to you. But for today, I'm mostly just going to be showing you how you can replicate most of the necessary parts of your desktop environment on the cluster. So yeah, these three goals. I want to give you a brief overview of how all of these things work, show you how to get files to and from. You'll probably have either data sets or scripts or both that you want to transfer. And then finally, just show you how to launch RStudio sort of the easy way. And the way I'm going to do that is I'm going to talk about the YCRC a little bit. I'm going to give you some diagrams of how the clusters work. I'm going to talk about the two graphical ways that people can interact with the clusters. There's a popular desktop client for Windows called MobaXterm that I'll briefly touch on. And then for most of the rest of the time, I'm going to talk about the open on-demand web dashboard that we have for our clusters. I'm going to show you a few things using RStudio, and then I'm going to talk a little bit more about like next steps. And if this is well received, we can also potentially plan some future workshops that sort of take you in the direction that I'm talking about. So very briefly, this is the Yale Center for Research Computing staff in the before times. We are a separate center from ITS, and we're also separate from the libraries. We're technically in academic services, and we answer to the provost's office. We have a couple of teams that operate under this umbrella. Primarily, the folks that you would be interacting with are either really technical engineers that help to design and maintain the clusters, or folks like myself who have some domain expertise and are your analysts. We help to get your work translated well to the cluster environments, and we also are often trainers and advocates of the scientific community in the context of like Yale administration. And then on this page, I also have our website and our documentation pages, which I will refer to later as well. So academic clusters have some general themes. A lot of them are bespoke machines, and oftentimes, if you go from one university to another, there will be differences, but generally, what you will usually find is that they have what's called a shared file system. So this is where data are stored. This is like an external hard drive for the entire compute cluster. It's oftentimes very fast. And the nice thing that it does is it provides you the same view of your files no matter where you are on the cluster, which simplifies a lot of things. The other thing that most compute clusters have in common is that they have what we call compute nodes. And this harkens back to when compute clusters had a lot to do with graph theory. So each of these servers that allows you to do your computation we call nodes, as if they are nodes in a graph. And then finally, the other common theme that you'll see is the login nodes. And that is where when you type your SSH command, or when you open up MobaXterm, or when you go to the on-demand page, those are the actual servers that you're connecting to that give you access to the rest of the cluster. So when you're connecting to the cluster, you actually are connecting to these servers, but where the actual work and storage of your work happens is on these servers. And they're all networked together in a data center over at West Campus at Yale. In terms of what kinds of hardware is available, generally these compute nodes have somewhere between 20 and 32 cores. Some have a few fewer, some have a few more. Also, generally, these compute nodes have at least 120 gigabytes of RAM total. And there are some that have 1.5 or 2 terabytes of RAM. So especially in the context of R, occasionally what we'll do is shrug a little bit and say, we could spend the next few days trying to troubleshoot why there's so much memory usage in this script, or we could toss it onto a very high memory compute node and it'll be done and we can all move on. And so we have that luxury on the compute clusters where we can value the human time over the compute time. And finally, I'll discuss this a little bit when we talk about submitting your RStudio job, but we have divided the clusters into what are called partitions. And you can think of these as just groups of nodes that we have designated certain purposes. And I'll talk a little bit more about that in a minute. The other thing that I'll mention, and that we usually spend a lot of time on, is the way that computation happens on the cluster is with a job scheduler. So you log into the login node, you ask that work be done, and then your work gets put into a queue and gets distributed out onto the compute nodes. The system that arranges for this is quite complicated, but the nice thing about Open On Demand is that we can sort of gloss over that for now, and then as your needs get more advanced, we can dig into that as necessary. But just to know that in the background, there's a lot of things going on that are quite complex. So I see there are kind of two general use cases for a lot of life science and medical computation to use one of the compute clusters that we have. And the first is sort of offloading computation. So even if what you're doing does run fine and sort of fit on your personal machine, either the desktop in your office or the laptop that you have in front of you, maybe you want to be able to use that machine for other purposes. Maybe you want to be able to turn that machine off and take it with you somewhere. And so leaving it on for hours or days to handle the work that you're asking it to do can become burdensome. So in sort of the simplest case, it's something that you could be doing on your own, but now you have sort of like your own, I guess you could call it your own little cloud that you're sending your work to. The sort of next step is that maybe you have, instead of one simulation to do, maybe you have now 100 or 1,000, or instead of 10 sequencing samples to analyze, now you have 200, or they've grown in size by an order of magnitude. The wonderful thing about these compute clusters is they scale really well in terms of the computation you need. And I'm going to talk a little bit about how that scaling works towards the end. The other nice thing about the clusters at Yale is that they are free is a loaded term. We and these clusters are part of the overhead that Yale skims off the top of all of the grants that we receive. And so for those of you who are PIs, you've already paid for this. So there's no additional fee for access to the generally available resources on these clusters. And then if you really like them, you can buy extra hardware or disk space to expand how much you use them. The quotas and disk space that we give you are, I would say, quite generous, especially compared to a lot of other academic computing centers. Again, in the cases where your analyses no longer fit on your laptop or desktop, either in terms of the amount of disk space you need or in terms of the amount of memory or RAM that you need, the cluster is sort of the next step that you can go to. And then we also have an extensive software library that we maintain, oftentimes of packages or pipelines that are very difficult to install on a Mac or Windows machine, if not impossible. And we spend a decent amount of our time trying to, duct tape and paperclip these academic pipelines together for you so that they can run on the clusters. And we also have a decent number now of compute nodes that have GPUs in them. And so this is really nice for image processing and the sort of machine learning pipelines that have become more popular. And finally, we have staff with scientific expertise and expertise with these systems available to help you. So this isn't like, going to the ITS help desk and we will continue to work with you after you've turned it off and on again. The things that the clusters are not good at is they run Linux, so Windows and Mac programs can't directly be run on them. Because of the model that we use for computation, the idea is there's some input necessary, there's computation that happens, and then the job that you've asked to have done finishes. And that's not the model that you have when you're talking about servers like web servers or databases. And so those things usually have to run off of the cluster, which you can access from the cluster, but don't really work well with a model of usage that we've designed for this. Graphical tasks are not ideal, but now more doable, and I'm going to show you that. Also, the way we look at these academic clusters is we try and invest as much in expanded capability rather than necessarily having uptime to rival cloud services that you might be more familiar with. So sometimes compute nodes may fail because memory goes bad or a disk goes bad, and so the longer a job you have runs without doing anything about checkpointing itself, the more you run the risk that maybe a failure could affect your job. And so things that run for a week or a day, I would never be worried about. But things that run for many months or something, we would try and work with you to figure out a better way to divide up the work that it's trying to run. And finally, something that is I think sometimes a surprise for folks is the hardware on the clusters. In addition to us trying to expand, as many cores as possible, is not always the newest and fastest CPUs available. And the reason that we do this is we invest more in sort of scaling outward. And so instead of having 10 of the fastest cores that Intel makes, these compute nodes will have many more cores that are maybe a little bit slower. The idea being, if you come to the cluster, you're looking to parallelize your work eventually. And so If you do have a small application that only makes use of a single CPU core, your brand new laptop will probably beat the same computation on the cluster. So just keep that in mind as well. The clusters won't always win a speed race if you have just one horse. Any sort of general questions about the clusters, our philosophy on them, what they're good and not good for? Pause just a couple of seconds to let people type. Okay. Well, I hope that was nice and clear. The next thing I'm going to talk about is getting access to the clusters. So the very first thing that you'll need to do is go to our website and request for an account. If you are not a PI, then you will need to ask that one sponsor you. Usually it's pretty clear who should fill that role, but if not, you can always reach out to us and we can help figure that out for you. Once you do have an account, we'll usually give you access to one, sometimes two of the clusters that we maintain. Excuse me. And if you are in the medical school or life sciences, often that is on a cluster called Farnham, or if you are doing work at the Yale Center for Genome Analysis, if you're getting sequencing done there, it's probably on the cluster called Ruddle. And Farnham and Ruddle, from a hardware perspective, are very similar. Ruddle is just a little bit smaller. These are their addresses for the login nodes, and then this is a link. These links are also on the clusters page, which I can show you in a minute. Sort of get like a dashboard view of the status of the clusters. The way in which we are starting to onboard folks more and more for cluster access is through this web service called Open On Demand. It is really nice because it's completely web-based. So if you have a modern browser, we typically recommend Chrome or Firefox. Safari seems to work pretty well for most things. I don't have a Mac, so I just don't get to test it as much. But this is nice because you don't have to deal with the forgivable confusion surrounding SSH keys or a lot of these command line options if you are more familiar with a graphical interface. So this gives you like a more smooth transition to the cluster, and then again, as your needs grow more complex, we can dig down into the guts of how all of this works. Each of the clusters except Milgram have their own Open On Demand instance, and that is typically just OOD -sign and then what the login node address is. And I'll be demoing that right now. So let's see if I click this. I can log on to Farnham. I'm going to make this a little bit bigger for you all. So this is on demand for Farnham. You'll see the same login message on the dashboard that you would if you logged in just via the command line. And then up at the top, there are some menu options. So I'm just going to go through them briefly. The first one is the Files application. So I can click on Files and then take a look at my home directory. And this is a file browser that starts where I would start if I logged in on the command line. I can, let's see, I can view text files. So I can take a look at some sequence data that I have. I can view images. So I can take a look at that. And I can also, let's see, I can edit text files with a simple text editor. So if I wanted to add new sequence, oops. And then I could save. And now if if I view this, you know, this is the new file, and that's on the cluster. So I don't have to actually bring files down in order to manage them in a pretty straightforward graphical way. I can also choose to download them if I want. And I think, let's see, if I drag and drop this, it should work as well. Yep, so this is on my computer now, and I can look at it on my computer. So that's the files application, which comes with it a nice a graphical text editor. Again, these all open in new tabs, so I recommend sort of having a separate browser window for all of your cluster access. The next is a jobs viewer, which is a nice way to track active jobs that you have. This will be a little bit more interesting once I've run some jobs. The next is a shell window, so I can run a command line interface shell, so I can use all of the Linux commands here and not have to manage a separate client and not have to remember where my keys are. So this is really nice. And finally, we have some interactive applications that you can launch. And I'll be showing you RStudio in a minute, but we also have MATLAB and Jupyter Notebooks that you can launch in a pretty straightforward way. Although the first time you do it, it might take just a little bit of setup. And we also have the option just to launch a generic remote desktop where you can start graphical applications that might not be one of the pre-baked ones that we have available. Patrick asked what kernels are provided with Jupyter. So the way that we encourage folks to run Jupyter is with Conda environments. So any kernel that is easily installable with a Conda environment is really straightforward. And then we have, we've gotten people set up with other ones. But the standard, you know, the Bash R, Python are pretty straightforward to run with Jupyter. And if we have time at the end, I can demo that a little bit as well. So I'll go back here. The other way that a lot of folks use the clusters is with MobaXterm, and I'm not going to spend tons of time on it today, but I have it open here. It has a silly little screensaver with penguins flying around after you leave it. It also has a file browser built into it by default, so I could, if I delete this sequence file, I understand this is probably a little bit small, but I'm dragging the sequence file over again, and I can transfer it that way, so it also provides a drag and drop interface, and then I can type commands in this shell as well. The one thing that MobaXterm provides us that is not possible through the web interface is a remote window rendering protocol called X11. And there are certain applications that maybe you would want to run just the window for and not have a full-blown desktop session. And if that is the case, reach out and work with us. But this is the only way to do that on Windows, and then on Mac, there's a special server that you need to install on your computer. But so, for instance, if I type xclock, it'll take a second to start. This is sort of a toy example, but I have this clock is running on the Farnham's login node, not on my computer. It's just forwarding the window that would be rendered on the login node to my computer. And this is not possible on the Open On Demand. But usually we can get away with just launching a desktop session instead. So that's all I have to say about MobaXterm for now. I would be remiss without mentioning the SSH keys. If you plan on only using On Demand for now, you can turn off your brain for the next 30 seconds. But the things you need to know about the SSH keys is we have instructions on how to generate them, and then you should never share the key that's called your private key with anyone, including us. We don't want them. And that once you've generated those keys, we have a website you can go to that allows you to upload the public version of your key, or the public portion of your key, that will give any computer that has your private key access via this SSH protocol that MobaXterm uses, that terminal.app gives you access to. But the nice thing about on-demand is we don't have to worry about this for now. Questions about logging in and getting access more generally before I move on to how storage works at a little bit more granular level, and also how to transfer files in several cases. All right. Excellent. Just chugging right along. So there are myriad buckets of storage that exist in various places on the clusters. And I think, as you will find with a lot of aspects of these machines, they are complicated beasts. And if you really dig down, there's a lot of complexity. But for the purposes of this talk, I just want to talk about 3 places where you can have files, and then leave the rest of this for you to review later if you want. Also, feel free to reach out to us if you have further questions. But there are, for any given person on the cluster, there are 3 quotas that you need to worry about. There's one called your home directory quota, and this is, your home directory is where you see when you log in. It's your own private space. It is the only place that we currently have the space and funding to back up. So that's very important to keep in mind. And the quota that you have there is roughly 100 gigabytes per person. And then you have 2 other quotas that are associated with your group. So again, when you sign up for the cluster account, you have to specify a PI, and everyone in that same group shares the next 2 quotas. The first one is for your project directory. You will see a shortcut to your project directory when you log in on your in your home directory, and I can show you that in a second. But the project directory quotas are usually somewhere between 3 and 4 terabytes, depending on the cluster. And then, so this is a good place for, relatively large but lab-specific data sets that you're actively working on. And then the final space where you have quota is the Scratch 60 directory. And this is really nice because it is by far the largest quota that anyone has by default. And it's really great for, if you're trying a parameter sweep and you need to generate just a bunch of files you don't necessarily care about, you just want to have a good temporary space to work for a few weeks or a month or so. This is the place to do that. We will periodically delete files that are older than 60 days there. And you will get an email the week before that happens instructing you on how to see which files will be deleted in the next week. And then if for some reason you need to be granted an exception, you can always reach out to us, and we can work with you on how best to manage those files going forward. There are some other places where files can be on the cluster, but for now I'm going to leave those out. If at the end you have questions about them, we can go over them. So generally there are 3 ways that we talk about transferring files to and from the cluster. There are some command line ways to do so, and they are related to whether or not you're copying things to and from a computer that you're logged into with SCP or rsync, or copying things from somewhere on the internet to the cluster with curl or wget. I'm not going to go over those today because I'm focusing as much as I can on just graphical things. So the way that you can get files from your machine to the cluster today that I'll show you is with on-demand. I already showed you that with some small files, or with MobeXterm. And then if you have lots of files or really large files or some combination thereof, we do have licenses for a service called Globus, which, you know, I think, shoot, Rob was, how big was that transfer Rob was working with? I think we have a 70 terabyte transfer going between Princeton and us right now. That's moving very smoothly. Now, the other two ways of transferring files just wouldn't be able to handle that in a good way because, you know, if it gets interrupted, bad things can happen. I'm gonna go to the next slide. So again, if you just want to copy some scripts or some medium-sized data, we recommend one of these applications. On Macs, I think the favorite graphical client other than on-demand right now is CyberDuck. I'm not going to go over that today, but if you're looking for one, go and get that one. You can get it for free, even though they offer it for money in the App Store. And we have instructions on our website about how to set that up. And then just one more plug for Globus. It is the best and most reliable way to transfer really large gobs of storage. And if there's interest, again, at the end, I have plenty of directions we can go in depending on what people are interested in. And finally, on Farnham and Ruddle, there's a directory on Grace as well. We have an area for what we just call data sets. So it's kind of wasteful in terms of the storage on the cluster if everyone had their own copy of HG19 or, you know, name your reference genome. So if you have a relatively well-used public data set, we're happy to put them in a sort of world readable place. And that way, we don't see a bunch of duplicates of that data, and then you don't have to have that counting against your quota. So we see it as a win-win for all parties involved. And we're always putting new stuff there. So I think we also have relatively up-to-date copies of the nucleotide and non-redundant BLAST databases there. So you can do a lot of big parallel BLAST searches without hammering the NCBI servers and getting us banned from them, which occasionally happens. So that's nice too. I think that's all I have to say about data sets and transfers. Show of hands. Would anyone like for me to do some more file upload download, or are we happy to move on to the main event, RStudio? Okay, I see no yeses. So I am going to continue on.
There is a yes, and there is a please show us.
Okay,
also.
we will,
yeah.
I'll do some more file transfer stuff. So let's see, I'm gonna pop back to the od-farnham.hpc.yale.edu. That's a little bit small, I apologize, but that's a website for on-demand. For files, I would go to my home directory. I can see this view. I can sort of drill down into, let's see, what would be interesting. Maybe my project directory. I could go look at an R file. Here's just a simple plot that we're going to go over later. I can drag this down to my desktop. I can open it. Can look at it. If I had, let's just make, so if I had a new file and I wanted to transfer it, I can also just drag it into the browser window. And if I let go, that will transfer that file to the current directory that I'm looking at. And you can view it to make sure, yes, this is that file. Again, if you have like 100 big sequencing data sets, this isn't the best way to transfer those, but we've had people do it and it's worked. So yes, you can also use WinSCP. Again, for MOBEX term, CyberDuck and WinSCP, you have to have your SSH keys set up. So the nice thing about the on-demand interface is you just have to be able to log in with CAS and you're good to go. So it takes a little bit less setup is all. And that's why we find, especially folks starting out, this is a nice way to begin there. I can also make new files and new directories with these buttons here. Right now, we don't have a connector between. So the question is it possible to transfer big files from Box to Globus? The best way to do transfers from Box to the clusters is with a client called rclone, which is a command line client. But once you get it set up, it's not awful to use, and I've recently helped folks get that working with Box. And here are all the different cloud providers that they support. So you can use it with Dropbox, you can use it with Box, you can use it with the Googles, you can use it with the Amazon, and some other strange things. I'm not sure we'll have time to go over how to use it today, but this is the direction I would point you in if you wanted to do a lot of cluster to Box transfers.
I would just interject to say that if this is something you want to see and survey at the end, please mention that you want to see this, and we can offer that also as a session. So thank you for the suggestion.
Yeah, we could do an rclone session if there's interest. Oops. So now I want to get started with RStudio. So we have some time for questions at the end. Before I show you how to get RStudio launched, I just want to talk about some of the best practices and being a good cluster citizen when using RStudio. So because RStudio is happy to sit staring at you and not do anything, what can happen is if you have an RStudio job launched and maybe you get distracted or you have to leave your computer, it can run for hours not doing anything. And we see that as a waste because those are resources that other folks could be using, and oftentimes there's a wait for those resources. And so sitting on those idle resources is not the best thing to do. A sort of subset of that is we ask that if you know that your R job is only going to need maybe as much RAM as your laptop has, don't allocate more than that, because again, those are resources that other folks could be using. And we have on the clusters set up a system that the scheduler calls fair share. And so if your lab group is using a lot of resources, the next time you contend for cluster resources with a lab group that has been more efficient in their usage, they will actually get to launch their jobs before you. So we try and reward those who efficiently use the resources that they have available to them. Once you decide you need to run lots of copies of your R script, we ask that you don't use RStudio to do that, because RStudio wasn't built for that in this environment. And also it's not an easy thing to do. And so we have better ways of doing that, and I can allude to that, and we'll probably have a session about that at a later date. And the last thing that can creep up on you is, and I'm going to show you how to do this, but only install R packages on the oldest available nodes. And the reason for this is when you install an R package, oftentimes it comes with code that needs to be compiled. Like, for instance, it's written in Fortran or C to make sure that it's faster than if it was just pure R. The wonderful thing that R does is it looks for all available optimizations that it can use on that code when it's compiling it to make it very fast on the CPU architecture that it is running on. And the way that the Intel CPUs work on the clusters that we have is that right now, at least the newer Intel CPUs have interesting new instructions that they understand that can increase the speed of your computation. And the newer ones understand all of the instructions on the older ones, but the older ones don't understand all of the instructions on the newer ones. So if you compile your, and Alicia, I'll get to that in a second. If you compile your libraries on an old node, they will work everywhere. But if you compile your libraries on a newer node, now all of your R computation is limited to just the newest compute nodes. So when you are planning on installing new libraries, just make sure that you use a job constraint. The way to do this in the interface to launch RStudio, the application and on-demand, is by adding this _ constraint equals oldest to the additional job options text box. And if you are launching jobs on the command line to do so, it's actually the same option to Slurm. We're just passing these directly. And if that doesn't make any sense, just ignore me. I'm going to show you now myself installing an R package with RStudio. So I'm going to go over to the interactive apps and click on RStudio Desktop. I'm going to get a form. I can leave the RStudio versions set right now. We're working on getting 1.3 ready for production, but we don't have it ready yet. Same with the R version 4. We've had some issues with a couple of the optimizations that we usually provide with our numerical libraries. So for now, we're just using a fairly recent version of 3. For most of what anyone does, this isn't an issue, but if it does become an issue for you, always reach out to us and let us know. And then you have to make some decisions about what kinds of resource requests your job needs. Typically, you won't need more than a few hours to install your libraries. So maybe I would just say 2 here. Number of CPUs, maybe I need 1 or 2, so I'll leave that there. I don't need any GPUs for this job, so I'm going to leave that at 0. And my laptop that installed it fine has 8, so I don't need more than 8 gigabytes of memory or RAM. And the partition that you should use if you're not me is called interactive. So those of you who are trying to follow along, you might have to wait a minute, but you would type interactive here, and I'll show you a list of the available partitions in a minute. But for me, I'm going to go to a special place where I know that I'll be able to get resources quickly. You can, if you know you're going to have to wait a while, you can check this box, and Slurm, the job scheduler, will send you an email when your session is started so that you can go and log in. So that's nice, but I'm going to leave that unchecked. I'm not going to talk about these. They don't matter for most folks. If we're doing special content environments for you, this is a way to configure that. Again, if that doesn't make any sense, just ignore it for now. But the important thing is if I'm installing a new R library, I just want to make sure that I put this option in this text box at the bottom. And so after I've filled this out, I'm going to go back and double check. I can click launch. What happens is I go to a new page where it's listing, and if I had, an RStudio desktop session and a MATLAB session and a Jupyter Notebook, they would all be listed on this page. And once the job is launched, it'll tell me information about that job. So this has, it's running on one compute node and it has 2 cores. This is when it was created. This is the name of the compute node that it's running on. And you have some options as to how crummy the desktop session looks. I tend to leave these a little bit sort of lower image quality, higher compression, which can kind of look a little ugly, but overall it'll give me a better performance in terms of my interaction with the compute node. So I like to leave it there, but if, beauty above all other things, you can fiddle with these slider bars and you can go from there. So while I click on this launch, I'm going to go back through a few of the questions. So, estimate of resources. That is a perennial problem. I think, so in terms of number of CPUs, oftentimes 1 or 2 is all you need to start. And then, as you continue to understand what your scripts are actually doing, you might need more. But so the flip side to sitting on idle resources is that the fewer resources you request, the more likely it is that you get resources more quickly. And so to answer the average wait time question, it is incredibly dependent on the amount of resources you request. If you request all 20 cores of a single compute node, you may need to wait hours because there are likely lots of single or several core jobs strewn across the cluster that you will have to wait on them emptying from a single compute node that the scheduler has decided your job can run on in the near future. So the wait time is not something that we can reliably predict for you, but the general rule is that the fewer resources you request, the faster your job will run. And then if you already have packages installed on the cluster, did it install with oldest by default? We've been trying to make it such that if you don't say anything, you'll probably land on an older compute node, but we can't guarantee that without specifying that restraint, that constraint. If you have been running your R code and it worked fine, then I wouldn't worry about it for now. But if in the future you do get some strange errors when you try and run your R code, but only on certain compute nodes, that's a good signal that we might need to reinstall some of your libraries. And for that, we're happy to help. You just have to let us know that you could use it. Other programs like Python, yes, we have plenty of Python users. I think the staff of the center actually primarily, we're very Python biased. We like Python. We use it for a lot of our own projects. The Jupyter Notebooks is a good way to get started with Python on the clusters without having to have a lot of command line experience in Linux. Another question is, when do I need a GPU? The short answer is almost never, unless you know that your specific application is both able to use GPUs and also configured in such a way that it can use GPUs. You probably, the only thing that will happen is you will take away that GPU allocated to your job from someone else, and your fair share will go down so that the next time you ask for resources, you'll have to wait longer. let's see. So I can take a look at this. So this is RStudio. For those of you familiar with it, it should look pretty much the same, even though right now it's a little bit artifacted by me asking to have lower image quality. But what's actually happening on the compute node is the same as what would look like on your computer. Here are, I haven't installed very many packages for myself. So here are all of the packages that we provide as sort of the base in terms of what just comes with R on the clusters. The nice thing about a lot of these, and I'll show you in a second, is that we compile them against numeric libraries that R might not necessarily use by default, and so they will oftentimes just be faster by virtue of you running them on the cluster. I'll show you an example of this in a second. So, I'm just gonna create a simple matrix of numbers sampled from the normal distribution. And it's kind of a big matrix, and so it's gonna take a second. And the nice thing about RStudio, I get down on it sometimes because it can be an impediment to performance, but what it will tell you is for large objects, it'll tell you how much memory they're using. And so if I pull this over a little bit further, this says that this single matrix is using 762 megabytes of memory. And so if I know I'm going to be, working with several matrices of this size, I'll know that I can sort of try and start to plan around my resource requests for my job. And so say I just have a transpose of that matrix, and I paste it here. I just copied and pasted, and there's another one, and surprise, it's the exact same size. I think probably the thing that I like least about using this remote desktop application, and it's something that will probably change in a version of Open On Demand that will come out in the next year or two, but is not the case right now, is that because of restrictions in how browsers handle security, we can't share the clipboard between your computer and the desktop that you're looking at. And so if you want to paste something that you have on your clipboard, you have to, run it through this interface on the left. So you see, this is the clipboard of the compute node that I'm working on. I can paste text in, and then I can paste text here. For instance, if I wanted to say I had already copied this code, I've edited this clipboard, and now if I paste this, you'll see that I've pasted from this clipboard. So I think that's, in my opinion, probably the biggest limitation of using this virtual desktop is that the clipboard is a little bit more separated than sometimes we would like. Someone was having trouble launching Jupyter. I'll probably be able to handle that better in a one-on-one session afterwards. But so yeah, I can make another large matrix, and then say, and RStudio is really nice to me. It tells me, I don't think you have this thing installed that you need for your script that you just opened. So say I wanted to use the library or the package called ggextra, and I wanted to install it, I can click install, and RStudio will run the install that packages command that will install that for me. And ta-da, it's there. And now I can see in my user library, I have the ggextra package, and I can load it over there on the right. So once you have allocated the right job for yourself, installing most packages should be relatively straightforward, as I just showed.
Ben, I think there is a question also from popular packages such as DP, LYR, if those are installed by default.
Let's see.
Are
So
there base packages there that are already installed when we
the
launch our
tidyverse, I
system?
don't think we install by default. Oh, okay. So we have a version of dplyr available. If you wanted a newer one, you can always install it to your personal library, but I can load dplyr, and there we have it. So you'll see this is sort of the long path to where the packages for this version of R are located. I don't know, do we have all of the tidies? Yeah, okay. So we have not the newest, but a fairly recent version of the tidyverse available. So you could, load the entire tidyverse as well if you had some tibbles to work on. So, but again, if you want the brand newest version, you'll have to install it into your local library, and that should happen by default. But if you have issues, you should just reach out. So another question is, when you install packages, does the RStudio on the cluster always use the same CRAN mirror? I believe what it's configured to do by default is use the RStudio Cloud mirror, which is just a way for them to decide which mirror to send you to automatically. But if you wanted to specify a specific mirror for some reason or another, you can do that in the install.packages function, and there's an option to specify that explicitly. Okay. So I think I'm happy with that. I have my package installed. And so say I wanted to take those matrices that I just made and do some simple matrix multiplication. So I'll go back to my window, maybe make it a little bit bigger. That is another nice thing about this browser-based interface, is that the remote desktop session will resize itself pretty well just based on the size of my browser. It might have to blink at you for a second, but it does do that pretty well. So here's just probably the simplest way to try and measure performance is use the system.time function and then wrap it around some R function. So if I run this, I'm asking for matrix multiplication of the A matrix and the B matrix. And it'll take a few seconds because they're not small. And something that we will hopefully notice when it's finished is that the time it spent for me, which is the amount of time that I spent on CPUs, will actually be lower than the amount of time that the system counted me using. And what that's a good hint of is that this operation occurred in parallel. So you see that I used more CPU time than there was time elapsed. And so if we can do that again. So there's you can just have a terminal running in this tab here that's available by default. And I think, let's see, it's under Tools Terminal. If that runs away from you, you can ask for a new terminal. There's a Linux command called top, and I can ask for just processes that are mine. So this is my netid. You would put your netid after the -u. This is a little process watcher. And this is also a really good way to understand your resource usage. The columns that are important to pay attention to are this one called res, and this is the resident residence at memory usage. And let's pretend like that is just the amount of RAM that your application is using. So you see right now, my R process is using 3.2 gigabytes of RAM. And so if I wanted to be like really, really optimistic that I'll never use more than that. Maybe in my next job request, I could ask for 3.5 gigabytes. Oftentimes, though, 5 would be a perfectly reasonable amount to request and be safe. And so you don't have to be dramatically efficient in order to be a good citizen. It's just, if I know my job is only going to use 3, I shouldn't request 15. Question is, when we install a package, does it go into our personal library? Yes. So we've set up these R installs so that only YCRC staff can edit the shared install that everyone sees, so that everyone can have their own personal R libraries, and packages that you install won't affect or contaminate other people's R libraries. So I'm just going to run that matrix multiplication again, and I should see a similar user in elapsed time, but I'm going to go back to this terminal window, and I should see something interesting happen. Oh, except for RStudio is frozen up a bit too. So another way to get a terminal window is this Linux desktop has that you can consider this like the start menu or the finder place. If I go look in System Tools, I can open a separate terminal window that won't get bogged down when RStudio is chugging away. And so if I run that top -u b e59, oh, it already finished. Try it again. So we should see this %CPU pop up to, so recall I asked for 2 CPUs, and because of the way that we've configured R, it's using both of the CPUs allocated to this job for that matrix multiply. And that's why you see that time is the amount of CPU time I spent is roughly double the elapsed time. And so the cool thing is we're getting parallel computation without having to rewrite code at all. And so that's sort of like the lowest level of parallel that you can get is just for free. We hopped on the cluster, and now we're using all the cores that are allocated to our job. So that's pretty cool. Yeah, so the top command is a good way of also monitoring your resources. Again, the %CPU, 100% is 1 core or CPU, and 200% is 2 cores, 400% is 4, et cetera, et cetera. And then the place where you can track how much memory is being used by a specific process is this RES column, or the residence set here. And you can also pay attention to that just by tracking how large your big pieces of data are in RStudio. So there are also several ways in which your jobs can fail. So the most common ways that R falls over are either the CPU instructions that I talked about earlier, or if you try and use more RAM than your job is allocated. And depending on the context in which that happens, you might see any kind of the following errors. I'm going to show you just R falling over and suddenly exiting, but also if you're submitting jobs as batch jobs, you might see the error called bus error, or errors with the OOM in front of them, which is out of memory. And you'll also probably end up seeing what are called core dump files. And I'll show you that in a second too. So let's go back here, and I'm going to try and make a sillily large matrix. I'm just going to add another 0 here and another 0 here. And see what happens. the meantime, I'm just going to go back and make sure I didn't miss any other questions. I don't believe so.
There is a question about once you install a package, whether it stays there. It does, right? So
yeah, so when you run
install.packages,
those will be saved to your, by default, a directory in your home directory. So they're also backed up. That command for that status window. Oh, and to quit, you hit Q. I forgot to tell you. Oh, so our session just suddenly stopped, and that's because I tried to use more memory than my job was allocated, and what happened is R froze and crashed when that happened. And so this is what happens when that's one of the ways in which that can happen. This should also probably disappear shortly. If I refresh. Yeah, so it entered a bad state. And so that's what it looks like. It might look like if you try and use too much memory. I'm gonna launch another one real quick. Maybe ask for a bit more memory. And then Theo, I'm gonna show you again how to get that status window back up. Okay, so I click this, and in a new tab I get, and you'll see RStudio is nice enough to kind of remember the layout of how I had it set up before. So that's nice of it. So again, to have that separate window showing me some basic usage is the command top, and then a space, and then a minus sign U, and then your net ID. So mine is BE59. So I hit enter, and I should see a window like this, and I can resize it. And again, the columns that you should be most interested in are the RES and the %CPU and the command. And that'll tell you how much memory things are using, how much CPU time they're using, and then which command they are. So I just wanted to go through another example, and this is one of the ggplot classic examples. I'm just using the mtcars dataset that is pervasive in R, and do maybe an interesting plot or two. And if I make this a little bit bigger, take a look at maybe P2. And so I generated, a scatter plot with marginal densities on the side. And if I export this, say maybe as a PDF, in density .pdf, and I click save. So what happened? Well, this drawer looking icon, if I click on that, I can actually go and view files in my home directory. And so you can see there's my PDF. I can go and look at it with the PDF viewer on this system. But I can also, if I go back to my my on-demand dashboard, I can go back to the Files app, and I can scroll down, and there's my densities. Let's see what happens when I view this. Yeah, so I can view it. I can also download that and take a look at it on my computer. So even though you can't copy and paste those images directly, you can save those graphics, and then if you wanted to do some finishing, or if you wanted to email this to a collaborator, it's relatively straightforward after you've saved it to just pull it down from the cluster with this, this interface here. So again, now that you have RStudio on the cluster, the clusters that really shine when they are doing parallel computation for you. And so the most immediate and simplest way is for some of the basic functions that R provides or certain libraries provide. We've tried to, where it's really easy to do so, implement the necessary math libraries and settings so that those just happen for you. I think that's all I have to say about that. The sort of next step into parallelism that you could take, and we have a workshop that is a little bit more general about how to do parallel R, and then we could probably talk about having one that deals with some of these tools, but you can have R handle the parallelism for you. The issue that you'll run into probably pretty quickly, though, is that once you try and scale your R code off of one compute node, RStudio doesn't help very much. Some of the ways in which RStudio Cloud function, you can distribute work in interesting ways there, but in terms of academic compute clusters, RStudio just doesn't scale well across compute nodes, and so it'll take a little bit of education and a little bit of work in order to take your R code and adapt it to use one of the example packages I list here. There are others that we demonstrate in our parallel R class, but in various ways they either will take your computation and distribute it across cores on the machine that you're on, or across workers that are spun up across many compute nodes. And this is the way to achieve really high performance distributed computing, but there's overhead in doing so because you have to decide how those things are scheduled, how your data are sent to these various workers, and so it takes some planning and understanding of how these parallel processes are working in order to do well. Again, we have a workshop on this, and we could also probably do a workshop on one or more of these packages. I think that the biggest downside to using the native R ways of doing this kind of parallelism is oftentimes you're left with an R process that has to be alive for the lifetime of the computation that you want to have happen. And so oftentimes that ends up being like a separate job that has to sit and wait for other jobs to start and finish. So it makes it hard to sometimes anticipate how long your computation needs in order to finish. And so a more generalizable approach to this is by using a facility that the scheduler provides, and these are called job arrays. And the cool thing about them is the scheduler handles the parallelism for you. It will, so say I wanted to have 100 sequence files analyzed with an R script. I could, instead of inside my R script, decide on how each of those files gets pushed out to the workers that I'm spinning up and how many workers do I need to create. What I can do is write an R script that processes one file, and then all I need to do is figure out how to tell that script which file and vary that. And so I can write a really simple text file that just has a list of the commands that I want to run, and I hand that off to the scheduler, and the scheduler will take care of the rest. It'll say, okay, well, there are resources free over there, resources free over there. I'm going to run these for you, and when it's all finished, I can send you an email. And that's nice because you have to think a little bit less explicitly about how that parallel processing is working, and also you end up using the resources that are available a little bit more efficiently, because you don't necessarily need the sort of the total amount of computation that you're requesting available at any one time. It'll sort of like, as it can, work through the jobs that you've asked. There was one other thing. Oh, this will also be the best way if you've in the future wanted to use something that didn't involve R. So say you had a colleague that was doing some work in Python, or if you had a compiled program that you were using, this approach will still work as long as you can specify the individual separate jobs that you want to have done. I just have a few more things. So sort of after you get up and running and you're happy with your RStudio work, what to do next, we heavily encourage and are happy to help you along in your journey of investing in your computational skills. So some directions that you can take yourself in are learning Git for versioning your code. RStudio has some functionality built into this for this, but it's really nice way to be able to demonstrate to potential employers or other labs that you are serious about computation by saying, I have this code that I can give you, and you can see how it's progressed over time, and you can also go back and try and figure out what happened that made it work so poorly, which is sometimes what I end up doing for myself. Learning Bash, Python is also a really great idea. We have some courses on that. There are courses everywhere on the internet on those. We really love Python at the YCRC. We like the way it looks and the way it encourages you to think about computation. And then again, in order to really take advantage of the scalability and the parallelism afforded to you on by the clusters, you will eventually need to learn more about how the scheduler works. We have a couple courses on that, and our documentation pages detail this as well. And using job arrays for your independent parallel computation is probably the next step after that. We have a shared email that we all watch and distribute work around that you should always feel free to send us a message about questions or help or application specific questions. We maintain a documentation site that has a bunch of different pages about how to run specific applications, how to schedule jobs, how to monitor your resource usage. And we've also started using a Q&A site. It's not heavily trafficked right now, but it is part of sort of a national campaign to get people interested in and discussing what the granting agencies would call cyber infrastructure. So that's what that ask.ci is. It's ask about cyber infrastructure. And in normal times, we would have office hours every day, but right now we are offering virtual office hours. Usually best to reach out and ask for an appointment, and someone will try and figure out the best time to have a one-on-one Zoom with you where we can discuss your project goals and how best to achieve them. I think I used most all of our time. I will be around for several minutes afterwards, but I think that's all we have time for today. I want to thank everyone for attending, and pause for. I think Nur has a couple slides to give on how to do the survey, and then I'll stay around for some questions afterwards. So Nur, if you're there.
Hi, yes, I'm here.
All right, excellent.
Yeah, so I don't see any more questions right now, but please feel free to unmute yourself and ask any question you want to. Ben, thank you very, very much for that great presentation and showing us our way around the clusters, the open on demand, running our studio, and you know, all the things that come along with it. And in the meantime, I will share my screen and put up the link to the survey. If all of you can just take the survey before you leave the meeting, that will be very, very helpful for us. So let me quickly share that. Sorry. I'm just trying to find the link to the survey. In the meantime, if anybody has any questions, please feel free to ask.